Hello everyone and welcome to the lecture on Amazon EC2 auto scaling. So what is Amazon EC2 auto scaling? First, automatic adjustment of EC2 capacity. Amazon EC2 auto scaling dynamically adjusts the number of EC2 instances in your application to maintain performance and minimize cost based on predefined rules. Second, ensures application availability. It automatically increases the number of EC2 instances during demand spikes to maintain performance and decreases capacity during a down period to reduce cost. Number 3, optimize cost by matching demand. By adjusting the capacity based on current demands, it helps in reducing unnecessary cost by ensuring you only pay for what you use. Fourth, uses predefined metrics for auto scaling. Auto scaling policies are triggered by predefined metrics such as CPU utilization or network input output, making scaling decisions smart and predictive. Fifth, supports scheduled scaling actions. You can schedule specific times to scale your application up or down, aligning with business cycles and predictable load changes. Sixth, easy integration with AWS services. Amazon EC2 auto scaling integrates with other AWS services like Amazon CloudWatch for monitoring, allowing for seamless and efficient scaling process. Auto scaling groups, so core concepts. First, logical grouping of EC2 instances. Auto scaling groups treat EC2 instances as a logical unit for scaling and management purposes, optimizing resource usage. Second, automatic scaling and management, leveraging auto scaling features such as health checks and scaling policies. These groups ensure efficient instance management. Third, dynamic capacity management. The group size is flexible, allowing manual or automatic adjustments to meet the demand, maintaining the desired capacity through the scaling actions. Fourth, health check and replacement. Continuous monitoring of instance health with automatic replacement of unhealthy instances to ensure group integrity. Fifth, scaling policy and schedules. Utilization of policies for dynamic scaling in response to conditions and scheduling for predictable load changes, enhancing performance and cost efficiency. Sixth, on-demand and spot instances. Flexibility to use both on-demand and spot instances for cost optimization, taking advantage of unused EC2 capacity at reduced prices. Seventh, availability zone balance. Distribution of instances across multiple availability zones for higher availability and automatic rebalancing during scaling activities, ensuring application resilience. Okay, auto scaling group example. So, for example, the following auto scaling group has a minimum of 3 instances to start with. Then we have set up a desired capacity, let's say of 5 instances, and then we have in the configuration we have also set that maximum size of 9 instances. So the scaling policies that you define adjust the number of instances within your minimum and maximum number of instances based on the criteria that you specify. So if let's say there is a CPU utilization matrix that we are watching for, so it will take the aggregate across all the whole auto scaling group. So it will always try to keep minimum size of 3, but it will keep desired at 5 of the optimum number. But if CPU goes above a certain threshold, it will keep adding, and then maximum it will go up till 9. And there is a scale out scaling. So this is elasticity. So either it will scale out or scale in depending on the matrix that we have specified. So through the CloudWatch matrix, it will continuously monitor for that matrix, and it will shrink in or shrink out depending on the demand or the CPU utilization. So there are multiple metrics, but I'm just giving the example of CPU in this scenario. Okay, features of Amazon EC2 auto scaling. First, health monitoring and replacement. Automatically monitors instance health, replacing impaired instances to maintain desired capacity. Second, custom health checks. Allows the definition of application specific health checks, ensuring instances meet the application needs. Third, availability zone balance. Distribute instances across multiple availability zones, enhancing application resilience. Fourth, multiple instance types and purchase options. Supports a mix of instance types and on-demand or spot instances, optimizing cost. So you can have a mix of different purchasing option within the auto scaling group itself. Fifth, Automated spot instance replacement, automatically request new spot instances if the current ones are interrupted, maintaining the capacity. Sixth, load balancing integration, works with elastic load balancing to distribute traffic evenly across your instances. Seventh, scalability options, offers multiple scaling methods to adjust group size based on demand, improving cost efficiency. 8th, instance refresh, updates instances in an auto-scaling group when the launch template or EMI changes. 9th, lifecycle hooks, custom actions at instance launch or termination, enhancing management capabilities. 10th, stateful workloads support, offers features like scaling protection and custom termination policies to handle stateful applications. Okay, Amazon EC2 auto-scaling benefits. So first one, better fault tolerance. EC2 auto-scaling detects unhealthy instances, terminates them and launches new ones. This includes the ability to operate across multiple AZs for increased reliability. Second, better availability. So ensures your application maintains the optimal number of instances to manage current traffic demands, keeping your application accessible without manual intervention. Third, better cost management. Dynamically adjust the number of instances to meet demand, helping you save cost by only using what you need. Instances are launched as required and terminated when not in use, optimizing your AWS expenditure. Okay, now let's see the example of covering variable demand. So it looks like this. We have some capacity and it fluctuates over the day of the weeks. So this is a graph, how much capacity we have allocated. And so let's say this is the whole capacity, and then the available capacity, like this is how we have used, but the capacity that we have provided is up till here. So every day this much CPU, memory and compute power or storage is, let's say compute or memory is gets unused. So we are wasting extra money. So and some days when the demand is high, so it can actually overshoot. So this will be like so your application will underperform. So sometimes you are either wasting money or you are having bad customer experience, so one of it. So depending on the scenario, so you either you can over provision or under provision. Under provisioning will give bad user experience, over provisioning will make will cost you more money. So now with auto scaling, that it will, so depending on the demand, this yellow one, the CPU, memory can actually go up and down depending on the application usage. Okay, the next one is web app scaling. So in this case, let's say a production VPC and we have a web server fleet. So we have gave one web server, one app server, but this is the current capacity. For example, this is the current capacity, and these extra ones gets added only when the demand increases. So this is how web app scale. So it can be at web tier or the application tier. And third is distribute instances across availability zone for better fault tolerance and availability. So in this case, this one is, let's say you have a region in a one single region. If let's say US East 1, then you have 3 AZs, A, B, C, and you have a production VPC, this whole production VPC, and there is an elastic load balancer, and then you have web tier, app tier, and database tier. So what we have done is this will this auto scaling group is spread across multiple all the 3 AZs. So one will launch here, one will launch here, one will launch here, and if there is more, one will launch here first, then here first, and in the same order it will just distribute your load. So even if one whole AZ goes down, it will it will spawn new ones if there is a requirement in the other AZ. So it's like better fault tolerance and higher availability is offered to your end customers. Okay, next we'll see what are the launch templates. So launch templates. Launch templates specify instance configuration details such as the Amazon machine image AMI, instance type, key pairs, and security groups. This offers a versatile approach to launch EC2 instances. So launch templates is basically a template, as the name suggests. It's a blueprint wherein you specify the values like AMI, instance type, key pairs, security groups, etc., and you launch EC2 from that blueprint. Okay, versioning and flexibility. So it allows for multiple versions of a launch template. So you can have versions of the launch template, enabling users to create base configurations and then add specifics like AMI or user data for application testing. And this facilitates easy maintenance and iteration of configurations. Third, features and benefits. So recommended over launch configuration. So there was something called launch configuration earlier, but now that has been superseded. This is a newer version, newer technology, or can say newer approach. It's called launch template. So it is recommended over launch configurations, which was used previously for accessing the latest auto scaling features, such as support for both spot and on-demand instances. So there is a support for both. You can mix and match spot instances as well as on-demand instances, and specifying multiple instance types. So you can also specify multiple instance types, instance family within a single auto scaling group. And fourth, advanced EC2 features. It enables use of latest Amazon EC2 features, including systems manager parameters, the latest EBS provisioned IOPS volumes, EBS volume tagging, T2 unlimited instances, and more, further enhancing functionality and performance. Okay, now we'll see some of the auto scaling methods. So understanding auto scaling methods. First, maintains a fixed number of instances. So maintain fixed instances. Keep your auto scaling group at a constant size, replacing unhealthy instances automatically to maintain desired capacity. Second, manual scaling. Directly adjust the desired capacity of your auto scaling group or terminate specific instances as needed for immediate control. So you can have fixed number, or you can manually scale up or down if there is a requirement to do so. Then scale based on a schedule. So automate scaling options based on a predictable demand patterns, aligning resources availability with expected traffic. Fourth, scale dynamically based on demand. So utilize scaling policies to automatically adjust capacity in real time, ensuring optimal performance amidst fluctuating demands. So this is the fourth one, which is I talked about, based on some metrics like CPU, network IO, etc. Then fifth, scale proactively with predictive scaling. Combine predictive and dynamic scaling to proactively adjust resources ahead. Like, so if you are expecting some Black Friday sale or some kind of a, like you have just opened some kind of big business, like going to public or something, then you can have this kind of predictive scaling. So you can combine predictive and dynamic scaling to proactively adjust resources ahead of anticipated traffic patterns, ensuring readiness for both daily and weekly fluctuations. So set scaling limits for your auto scaling group. First, minimum and maximum group size. So this defines the boundary for the size of your auto scaling group, ensuring operational flexibility within predefined limits. So let's see those capacity, like those configuration. First is desired capacity. So initial group capacity at creation, aimed at maintaining this level, barring scaling policies or scheduled actions. Next configuration is minimum capacity. Ensures scaling policies do not reduce the group size below the minimum set limit, safeguarding against inadequate resources. And fourth, maximum capacity. Prevent scaling policies from exceeding the group's set maximum size, controlling your resource overutilization or cost. Then fifth, manual and scheduled scaling impact. The ability to adjust the group's desired capacity manually or through scheduled actions within the set limits. And sixth, auto recovery of desired capacity. So automatically launches new instances to maintain a desired capacity in case of unexpected terminations, ensuring resilience and continuity. Okay, elastic load balancing with auto scaling. So let's see elastic load balancing. This elastic load balancer or elastic load balancing supports auto scaling groups. So in this elastic load balancer, there will be target for auto scaling group, and this based on the matrix, it will trigger to scale in or out depending on the signal that it gets from here. Okay, so first is automatic traffic distribution. Distributes incoming application traffic across all EC2 instances evenly, preventing any single instance from being overwhelmed. Second, attach load balancer to auto scaling group. this simplifies setup by acting as a single point of contact for incoming web traffic, enhancing efficiency. Third, no manual instance registration needed. Instances launched or terminated by the auto-scaling group are automatically registered or deregistered with the load balancer. Fourth, use elastic load balancer matrix for scaling. So this allows for dynamic scaling of instances based on demand, utilizing elastic load balancing matrix like the application load balancer request count. So let's say request count is one of the metrics. So if you are getting above 1000, 10,000 request count, you can either increase or decrease the instance count. Fifth, optional ELB health checks enhances reliability by enabling Amazon EC2 auto scaling to identify and replace unhealthy instances based on load balancer health checks. So this can tie up directly with the load balancer health checks, so it can take action on EC2. Okay, next is event bridge for auto scaling events. So this is event bridge. So basically event bridge is a service that monitors resources and initiates actions using the other AWS services based on rules. So event bridge has something called events, and you can based on those events input the source and destination. So you can take action based on the what is the event data looks like. So second, real-time event delivery. So events from Amazon EC2 auto scaling are delivered nearly instantaneously, which allows for timely responses. So rules for programmatic actions. So you can create rules in event bridge that invokes actions or notifications in response to EC2 auto scaling events like launching or terminating instances. So if there is a termination or launch or some other activity, so you can have notifications, or you can take some action like a remediation action, or notify somebody in the sysadmin group or something, like whether it has it's below some health threshold, or it's below some certain, or it has reached maximum. So if it's reached maximum for let's say more than a certain amount of time, you can take action. So basically your application is actually running saturated for a very long time, let's say. And fourth, a wide range of targets. So there are targets, so there are source and targets. So source is your Amazon EC2 scaling events, and the targets, so event bridge rules can target AWS Lambda function. So if you have a target as Lambda function, you can do automatic remediation. So whatever code you write in Lambda function, that will just do it automatically. Then you have Amazon SNS topics. So basically for notification, push, app notification, SMS, all those things. Then you have API destination, so you can also integrate with other APIs, event buses and others. So this will help in diverse set of responses to an event. So you can mix, and not just one, you can put multiple combination of that together. So again, you can have Lambda function, SNS or API at the same time for a single event as well. And that's all. Thanks for watching.